Now, generally for ionic compounds, right, you want to refer to the solubility table for these ionic compounds to determine the state symbol, right? To determine if it's a solid or it's aqueous, means it's dissolved in water. Okay, so for a solubility table, there are rules that we have to follow, right? And they kind of go in order, right? And you should use this solubility table and memorize it, okay? So that you can easily reference this in your head when you're determining the state symbol for your ionic compounds. For example, your group 1 and ammonium ion, right? Any ionic compound with a group 1 cation, like Na+, okay, or ammonium cation, right? These are all definitely soluble. Same thing for ionic compounds with the nitrate anion, okay? If you have the chlorine or the bromine anion, it really depends what the cation is. Most of it is soluble unless the cation is Ag+ or Pb2+. So for example, right, your AgCl, this is insoluble. Next, we look at our sulfates. Okay, for our sulfates, all are generally soluble except the Lead2+, Ba2+, and calcium2+ cations with them. Okay, so for example, like calcium sulfate, this is insoluble as well. And then lastly, okay, for your carbonates, your hydroxides, and your oxides, these tend to be insoluble, right? Except if you follow like rule number 1 over here, if it has a group 1 or ammonium cation. Okay, so for example, like your calcium carbonate, right? This is generally insoluble. Your calcium hydroxide, your magnesium oxide, these are all generally insoluble ionic compounds unless it has a group 1 or ammonium ion. So for example, right, sodium oxide. This is soluble in water.